Good afternoon, everyone. We are now moving on to lesson 6. And actually this part of unit 1, because we're still in unit 1, is all about solving. So now we're going to get into solving. Today for lesson 6 is solving exponential equations. So let's talk about exponential equations. So our first concept is exponential equations. An exponential equation is an equation that contains a variable in the exponent that you are trying to solve for. All right, so now our first solving concept is solving exponential equations using a common base. So if two powers of the same base are equal, then their exponents are equal. Now, you may have to use some properties of exponents to simplify an equation first before solving, but we'll get to that when we get to that. So our first example here is 4 to the 5x equals 4 to the 3x. So as you can see, both our bases are the same, which are 4. So that means our exponents are going to be equal. So we can just drop the base and have 5x is equal to 3x minus 8. And now all we have to do is just go through and solve. Subtract 3x from both sides. 2x is equal to negative 8. Divide by 2. And we get x is equal to negative 4. So this next one, same thing. 2 to the 3 times x minus 1 is equal to 2 to the 7x plus 9. We have the same base, so we're just going to take what's in the exponent spot and set them equal to each other and solve. So 3 times x minus 1 is equal to 7x plus 9. So the first thing I'm going to do is distribute the 3. 3x minus 3 is equal to 7x plus 9. All right, I'm going to subtract the 3x. Negative 3 is equal to 4x plus 9. Now I'm going to subtract the 9. And we have negative 12 is equal to 4x. Divide by 4, and we get x is equal to negative 3. Now, you may have to do some properties of exponents first before you set everything equal to each other. So this first one, we have 9 to the 3x plus 2 times 9 to the x plus 3 is equal to 9 to the 2x plus 17. So everything has the same base. So we know these exponents are going to be equal to 2x plus 7. But remember, with our properties of exponents, when we multiply the same base, we add their exponents together. So we're going to add the exponents and then set that equal to 2x plus 17. So 3x plus x is 4x, 2 plus 3 is 5, and that's equal to 2x plus 17. Subtract 2x. 2x plus 5 is equal to 17. Subtract 5. 2x is equal to 12. Divide by 2. X is equal to 6. All right, last one. 10 to the 5x minus 7 divided by 10 to the 2x minus 3 is equal to 10 to the x minus 10. All the same base. So we're going to set it equal to x minus 10. But now, with our exponents that are being divided, remember with the same base, we subtract them. So 5x minus 2x is going to be 3x. Negative 7 minus negative 3 is going to be minus 4 is equal to x minus 10. So now, solve for x. 2x minus 4 is equal to negative 10. Add 4. 2x is equal to negative 6. Divide by 2. And we get x is equal to negative 3. So there we go. Exponential equations with a common base. Now we're going to look at solving exponentials by rewriting them. So this is when you don't have a common base and you only have exponential on one side. So concept, rewrite exponential equations using logarithms. Whoops, sorry about that. So if you are trying to solve an equation with a variable in the exponent not set equal to the same base exponent, you will want to rewrite the equation as a logarithm. Then you will use the change of base formula to solve for the variable. So first we need to recall how to convert. So converting an exponent to a log. B to the x is equal to y. So this is going to be log b of y is equal to x. We also have to do the same with natural logs. So we have e to the x is equal to y. So this is going to be the natural log of y equals x. And then finally, just a reminder of what the change of base formula is. Log base b of m is equal to log m divided by log b. All right, we're going to start very simple here with our first two examples. So, step number 1. Rewrite as a log. So 4 to the x is equal to 17. So this is going to be log base 4 of 17 is equal to x. And then step 2. Change of base. So we cannot calculate log base 4 of 17. But what we can calculate is log 17 divided by log 4 is equal to x. So now it is just calculator work. Log 17 divided by log 4. And we get 2.04. All right, our next one. We start the same. We need to rewrite this. Don't let the exponent on the other side fool you. Our base is 7 of 41 is equal to 3k. Change of base. Log 41 divided by log 7 is equal to 3k. Log 41 divided by log 7, 1.908 is equal to 3k. Now, there is still one more step we need to take. We now need to divide by 3 to get k by itself. So we get 0.636. All right, that's our first page. We are now going to move on to page 2, where the problems are going to get a little bit harder.